Hey guys, I'm not here today because I have a doctor's appointment or something is going on in my life that I cannot be here. So I will be here later this afternoon, just in time for A-Lunch tutorials. So if you need to finish your test, come in at A-Lunch and we can get that taken care of. And then if you have any other problems or anything, you can come in at A-Lunch and come and see me. If not, I will see you tomorrow. But in the meantime, we do have some work today. We're doing proportional versus non-proportional relationships. And so you should be filling out notes with me today, and then you can start doing the practice problems. It's a concept that you guys went over in 8th grade, so you should be okay doing these. So you can go ahead and tear apart. I'm going to take my staple out. I'm going to be careful about it this time instead of just ripping it. Oh, just ripped it. Okay. Top part, go ahead and take your practice problems, put them to the side, write your name on it, that sort of thing. Just put it away for now. Relational, non-proportional. It's a foldable, so we are going to fold towards the middle like we usually do. There is no cutting involved with this, so you do not need the scissors. You'll be just fine without them. Okay? Proportional relationships, non-proportional relationships. We're going to talk about the difference between the two, and then the practice problems basically ask you, is it proportional or not proportional? And that's all you have to answer is yes or no. Alright, so for now, for our notes, we're going to focus on the left side, proportional relationships. If the equation passes through 0, 0, that's the origin, and is of the form y equals kx, so that's like direct variation, which we did in this previous unit, then the relationship is proportional. So if you're going to take notes with me, draw a box around that because that's what we're highlighting, or you can use a highlighter and go ahead and color that. We're also going to circle this because we want our equations to be in that form. We do not want to have a plus b. We don't need a y-intercept of any number except for 0. So we have our first example. It says y equals 3x. We want to see if the relationship is proportional. So we're going to take our y value and put it over the x value for the first point, and then we're going to see if it's proportional with the second point. So we're going to put -3 over -1. So far I have -6 over -2. Is that equal to -3 over -1? And we can plug that into our calculator. I think I showed you guys how to do it before. You're basically going to pull up a calculator screen. So let me clear mine out really quick so we can see it better. I'm in the calculator screen, and I'm not doing menu 3-1. I'm not doing number solve. I don't need that. I just need to test and see if these two equations are equal. So I'm going to type in -6 over -2, and then click the equal sign. Control divide gets me another fraction, and I've got -3 over -1. When I hit enter, it tells me if they are equal to each other, and if they are, if it's a true statement, then that means that they're proportionate to each other. So I'm going to write test up here. I'm going to say that we did our y values over our x values to see if they are proportionate. So we didn't have to cross multiply. And then if they are, if it comes out true, that means it's proportional. And I'm just going to abbreviate that propor. Okay? And this next part, pretty easy. We're just graphing it. And so whatever points are in the table, I want to go ahead and plot those. So I've got -2, -6, here's -2, -1, -2, -3, -4, -5, -6 is off the paper. So maybe I move to the next one. I say -1 and -3. So here's -1, count down -1, -2, -3. Put your point. The next one is 0, 0. Put a point at the origin. And then the other point that we can graph is 1 and positive 3. And because this is a function, it is a continuous relationship, we can go ahead and draw a line through those points. And then because it goes through 0, 0, that's a good thing. And then it has a constant relationship of 3 over 1 as its slope. I'm going to grab another color for that. So it basically grows 3 over 1 every single time it changes. So 3 over 1, 3 over 1. If it grows the same amount each time, then that's a proportional relationship. Okay, but it has to have the constant rate. And it needs to go through origin. Okay, so moving that up so you can see a little bit better. And since this is a video, if you didn't catch all of that, I'm sure you can have my substitute, I think it's Mr. Glover. You can have him rewind it a little bit in case I went a little bit too fast. You can also ask me tomorrow maybe to kind of fill in some of the gaps, but try to write down what you've got so far. And then we're going to move on to what is a non-proportional relationship. And the thing about non-proportional relationships is they look similar to a proportional relationship, but there's one difference, and we'll check that out in a minute. So non-proportional relationships here on the right. If the ratio of the value of x to the value of y is different, okay, so I put, you don't have to make it perfect like that. I just wanted to draw my eye to it to realize that, hey, it's different. For the select ordered pairs on the line, so all my table values, that sort of thing, the equation is non-proportional. Okay, so our first example is going to be y equals 2x minus 1. So again, I'm going to take y values and x values from the table. I'm going to start with my first one here, negative 5 over negative 2. And I'm going to see if that's equal to the second value, which is negative 3 over negative 1. And again, I'm going to test that in the calculator. So control divide gets me a fraction. Negative 5 over negative 2, is that equal to negative 3 over negative 1? And when I hit enter, it tells me it's false this time. So that tells me they are not equal to each other and that it's false. So that means it is non-proportional. And I'm going to abbreviate that again. So I did the y over x test to see if they're proportional with each other. The other thing that I'll notice, so that's if you have a table, if you're looking at a graph, this is going to graph not going through 0, 0. The y-intercept is a negative 1. That's my b value. My m is a 2. So if my b value is a negative 1, that means it goes right through 0, negative 1. Whereas on the left side, it went through 0, 0. So that in itself tells me, hey, something's not right. It'll be a constant rate, but it probably isn't proportional. So I'm going to count my slope off really quick. 2 over 1, up 2 over 1, up 2 over 1. And then follow the pattern the other way. Go ahead and connect the dots. And because of this point right here not going through the origin, because remember, over on the left side we said it had to be a constant rate. We have a constant rate. But goes through 0, 0. We're going to draw a line through that. and put a sad face because it's not proportional. Okay? And again, if we need to back up a little bit, you can ask Mr. Glover if he'll go back and catch up with some notes or hit pause or something. Okay? So now we're going to move to the inside of our notes. Okay, we got a couple of problems with some tables that we can verify proportional or non-proportional. Okay, I'm working on the left side right now. Right now it looks like we've got gas used measured in therms, and then we've got total cost measured in dollars. Our graph here is total cost on the y-axis, gas used is our x-axis. So we want to write an equation for this. One thing that we can do is find out how much it's changing each time. So $2.60 minus $1.30. I can, well, actually, that's $1.30. I can take 260 and subtract 130. It's kind of like those arithmetic sequences we just did. I can do the same thing for this, 390 minus 260 in my calculator, and that should come out as a 130. I'll double check it one more time. 520 minus 390 in the calculator, and it should come out $1.30. So that's basically keeping the same the entire time. The rate up top for my x values is also staying the same, so my rate is basically 130 over 1, which is the same thing as 130. If I were to work backwards, this would 130 minus 130 would be 0. If I work backwards right here and to go backwards 1, that would also be a 0. So my rate is 130. My y-intercept would be 0. If I write that as an equation, it would be y equals $1.30 or 130 times x. So now I want to graph this. And using my table, I can say 130. So 1 and 130. So we'll say 130 is right about here. I am guesstimating the best that I can. I've got 260. So here's 2 going up to $2. A little bit past half is going to be 260. Then I've got $3.90. So that means I must be right below $4. And then my last point to graph for now is going to be $5.20. So I'll be just past $5. And then I noticed from my table that if I work backwards, I'm at 0, 0. So now I can connect all the dots. If I don't buy gas, I don't have to pay money, right? So that's where 0, 0 is coming from, basically. If I don't buy gasoline, I don't have to pay any money. But if I buy 1 gallon, or 1 therm, excuse me, then it would be $1.30. If I buy 2 therms, then it would be $2.60, and so on and so forth. So the next part says, what would be the cost of 40 therms? So we're going to use the equation y equals 130 times x, and the 40 is going to replace the x. So now I've got y equals 130 times 40, and I can plug that in the calculator to solve. Okay, if you do plug it in the calculator, let everybody know what you got. Verify with a couple of other people, you know how we do in regular class. Okay, so 130 times 40, I believe somebody's probably already called out by now. Y is equal to 52. And that would be $52. Okay, so that's a proportional relationship. That's what it would look like if we use the graph and the table, and also what our equation would look like. The next one we're going to do is down below. Write an equation in function notation for each relation. So that means instead of the y, we're using f of x equals. So right here on this equation, I want to identify what is the intercept. It looks like the intercept is at 0. And then I need to find a nice clean point where it goes through a graph mark, where the grid marks are. So it looks like I'm going like a pretty low slope. So it looks like I'm going down 1, so that's a -1, and then I'm going to the right 2. So here's my slope value. M equals -1 over 2. And that won't reduce anymore, so I can go ahead and leave it like that. This time I'm using f of x instead of y, and we're going to say f of x is equal to -1/2, and because 1/2 is my slope, I put the x after it, and then I can put +0 since that was my intercept. But if I want to simplify that, which would be really important to do, I'd say f of x is equal to just the -1/2 x, and I can leave it alone from that point. So moving on to the next one, again, my y-intercept, so my b value is at 0. And again, I want to find a good place to count my rise and run. So it looks like we're going down and to the right. If I go down, that's a negative, so -2. And if I go to the right, that's a 1. So down here I'm writing my m, which is my slope, is -2 over 1, which really means it's just -2. So then again, instead of using y, I want to use f of x, and that's equal to my slope value, which is -2. Put the x behind that because that's where how we designate it's our slope, and then we can say +0. And then we don't want to leave it like that, so again we'll write f of x is equal to, and we'll say -2x, and then we don't have to write 0 because we simplified it. We don't need to write a 0 when we simplify. So far so good. Are we okay? I hope so. If you have questions, I want you to make a quick note somewhere in the margins, or write it down on your notebook somewhere that you had a question about it. We can go over it when I come back and I see you on Tuesday. So hopefully that gave you enough time to write things down. We're going to switch over to the non-proportional examples. Okay, so I'm going to slide my paper over just a little bit. And let's see, complete each table of values, then write an equation in function notation. So again, we're writing an f of x. F of x equals, to write some of these. So right now, if I'm going to write an equation based off of a table, there's a couple of things that are important to me. First of all, the y-intercept that I'm looking at right now. That's where x is 0 and y is 2. That's pretty important to me. I need to use that. So I'm going to say this right here is my y-intercept. That's the b value. Okay? But I still need to finish out the table. I need to do some other stuff with that. So what I could do is, how much did it change to get from -2 to 2? So what I can do is I can say 2 minus -2 is how much? 2, 3, 4. Should be about 4. So then just double checking, 2 plus 4 makes 6, and so it looks like we're changing by 4 every single time. So 6 plus 4 should make a 10. Then we want to do 10 plus 4 makes 14, and then 14 plus 4 will make 18. So that helps us finish out the puzzle. It looks like we're changing by 1 each time. So from -1 to 0, 1, 2, 3, 4, changing by 1s. And so what we might do is just say, hey, let's take 2 points and do some slope formula just real quick to verify that our slope is 4. So I'm going to say, here's my y2, here's my y1, Here's my x2, here's my x1, and I'm going to do the y2 minus y1 first. So I'm doing 2 minus negative 2 divided by 0 minus negative 1. And I'm going to plug this into the calculator exactly how I see it. And when I do that, I've got 2 minus negative 2, 0 minus negative 1. And that gives me, I let the calculator do the whole thing at once, and that gave me a 4. So that's my slope value. That's my m. Okay, so far, now I have an m. Now I have my b. So I need to plug into y equals mx plus b. So y is going to be equal to 4x, and since that's a positive 2, we say plus 2. And then I'm supposed to write it in function notation, so I'm going to change that y to an f of x, and everything else is going to stay the same. Okay, so you can treat everything with y equals for a while, and then because they're asking for function notation, we do need to change that so that it's f of x instead of y. Okay, we're going to do this similar thing on the next table. I think I'll use a different color because I'm bored of that color. On this one, it looks like we're going from negative 2 to negative 1, 0, 1, 2, 3. So that part's taken care of. Now we're going from 10 down to 7, down to 4, down to, we got to finish that out. What is 10? Let's see, no, last time we did 7 minus 10. What's 7 minus 10? Should probably be a negative 3, right? So if we're doing that, let's just test it on the next one. 7 minus 3 equals 4. What about 4 minus 3 would make 1? And then 1 minus 3, just double checking myself, should make a negative 2. And negative 2 minus 3 gives us a negative 5. Okay, so we finished out the table. I think we did that first this time. Now I'm going to look at my table and verify and see if I can find a y-intercept. Remember, y-intercept is where 0 is for x and there's a number for y. So right about here, this should be my y-intercept. Okay, so I'm going to circle the 4 of that. There's my y-intercept, which is also my b value. Okay, I want to test my slope out. I think it might be negative 3, but just to be on the safe side, I'm going to make this my y2. This is my y1. Here's my x1. There's my, hello. Having a tough time today. Sorry, it's Friday afternoon and I'm ready to go home, but I'm doing this. Okay, x squared, sorry, x2. So x1, x2, and if you wrote the y's, I'm sorry, fix it. This one is y1, there's y2. Everything should be good now. Negative 2 is my x1, negative 1 is my y1. That's a 1. No, I'm having a tough time today. Let me fix this. Apologize. It's just like if it was class and I had to fix something in class. Alright. That was my x2. There we go. Sorry about that. Anyway, using slope formula, I'm going to take my y2 minus my y1. Then that's getting divided by negative 1 minus a negative 2. I'm going to type that into my calculator just as I see it. So 7 minus 10 over negative 1 minus negative 2, and it confirmed that we have a slope of negative 3. Okay, I'm going to push this up really quick because I feel like I'm running out of room. Okay, now I have my m, now I have my b. We've got y equals mx plus b that we want to fill in. So y is equal to the negative 3 followed by x, and then my y-intercept is going to be that positive 4 from the table. And again, I can't just leave it like that because they want function notation, so instead of y equals, I'll put f of x equals, and then the rest is negative 3x plus 4. Okay. The next part, hopefully will go a little bit smoother. It's just getting y equals mx plus b from the graph. Okay. So what I'm looking for right now is, it's good to look for the y-intercept first. I'm going to draw a little line to kind of block things out. My y-intercept is right here. My b value is, let's see, start with the origin, count up, 2. So my y-intercept, my y-intercept is 2. I want to do my slope value, and since it's a graph, I can count my rise and run. So to go from this point at -1 to go up to that y-intercept, it looks like I'm going up 2 and to the right 1. So that should be a 2. Now I have my m, I have my b value. So y equals 2x plus 2. Oh wait, write an equation in function notation. So we're going to change that f to f of x equals 2x plus 2. Because when we write things in function notation, we use f of x instead of y. They're basically the same thing. We talked about it a long time ago. But coming back to be practiced. Okay. It's our last one. Yay, it's our last one. Okay. On the right side, just making sure I can see it on the board. On the right side, my b value, again, it's at 2. My slope, though, let's count slope really quick. Not moving very much. Looks like it's going down 1 to the right 1. If I simplify that, that should equal a -1. So my slope is going to be -1. Down below, plugging into, helps if I lift it up. If you missed this because I didn't show it, I apologize. Here it is on the left, f of x equals 2x plus 2. That's on the left side. Switching back to the right side. Starting out, filling into a y equals mx plus b. Here's my m is -1. There's my x to show you it's my slope. Plus 2 because that's the b value. And again, because they want function notation, I'm going to put f of x is equal to -1x plus 2. And I can leave it like that. And I know one of you is saying, can't I just put -x plus 2? Yes, you can do that. That would be perfectly fine. They're the exact same thing. Thank you for asking that question. Okay, from this point, I want you to put this in your pocket. Do not glue it yet because we still need to make a unit pocket for Unit 4. And we'll do that on Tuesday when we're together. That way we can catch up with any pages that we need to glue in, that sort of thing, and we can just double check, make sure everything's good. And that's pretty much it. Now at this point you should be able to pull out your practice page, and all it's doing is saying write an equation in function notation. So that means you're going to use f of x instead of y as your final answer. So I'll be looking for your function or your equations to be f of x. And if I will move that over, you can see it. There we go. And then determine whether it's proportional. So on number 1, I'll just do number 1 with you. Here's my b at 1. That's my intercept. And then they luckily gave us dots this time. That's super helpful. So we're going to count down and to the right. Looks like I'm counting down, how many? 1, 2, 3. So if I go down, it's a negative. If I go to the right, it's positive. Looks like 1, 2, 3. M equals -3. That's my rise over my run of 3. Reduce that, and it's a -1. Plug it into y equals, and we've got -1x plus 1. But again, they want function notation, so we're going to change that y to an x. And now we're good. If you get to the point where you can see where to plug f of x without having to use y, then yes, you can skip that step and say f of x is equal to negative 1x plus 1, or whatever equation you're working on. You can skip this part to move on to this part if you can see it. If not, use this as a side step or maybe a baby step in order to help you get into this function down here. Okay, so that's how you're going to do the graphs and then your tables. Okay, the tables, it's harder to see because we don't have a graph, but I'm always looking for the point. Oh, one more thing, sorry, number 1. Is it proportional or not? The best way to check it on a graph is, did it go through 0, 0? I don't see it going through 0, 0. So out to the side, maybe on the left, I'm going to say no, not proportional. Alright, moving on to number 7 now. Number 1 was no. On number 7, nah, I don't want to do number 7, sorry. Number 9. I like that one better. Okay, number 9, I'm looking for my y-intercept. That's going to be where x is 0. Okay, so there's my y-intercept. So far so good. I need my slope though. And from a table, this is going to be my x1. Here's my x2, y1, y2. I know it says f of x. Remember, f of x is the same thing as y. I'm going to take my y2, which is 0. I'm going to subtract the y1. Put that over my x2, which is 0, and minus the negative 1. I can plug that in my calculator. Should be getting, I think, negative 3 over 1, which would be 3. I'm going to double check though in my calculator because, you know, that's what it's for. And yep, negative 3. So now I have my intercept, I have my slope. Plug it into y equals, there's the negative 3 as my slope. I know that because there's an x behind it, and then plus 0. As I simplify this, I'm going to go ahead and change it to f of x is equal to, and then we've got negative 3x. And because we simplified, we don't have to write the 0 afterwards. And I'm done with my equation. Last but not least, is it proportional? Well, it looks like it's going at a constant rate, so that's one good thing for it. And then the kicker, it goes through 0, 0. Remember, if it goes through 0, 0, that right away makes it proportional. So we're going to go ahead and say yes on number 9. Okay, you have the rest of the time to work on this. Catch up with the notes if we need to rewind or anything. You can also double check with your neighbor. This is going to take a little bit of time, but I would like to see what you do with it. So if you will turn it in before class ends, I will hand it back out on Tuesday, and we'll take a little bit of time to clarify, and you can ask your questions. Hopefully that was clear. If not, again, write down your questions, rewind if you need to, but go ahead and work on this. Do not glue in yet. We will glue on Tuesday, okay? So if you see a neighbor picking up a bottle of glue, tell them, hey, don't do that. Go put it back. We'll glue tomorrow on Tuesday, okay? I will see you guys. I hope you have a great day. And yeah, that's about it. Bye.